All right. So good morning, everyone. Welcome to the Engineering Solutions 101 workshop. My name is Harry Wu. I'm the presenter for today, as well as I'm the judging tomorrow. My manuscript on Discord, if you want to contact me through that. So I'll just be talking for a while without really any pauses. So if you have any questions, just feel free to interrupt. Don't feel pressured about the time or anything. I'd be happy to take a side topic as long as we feel it's beneficial. So a quick rundown of the topics I'll be discussing today. So we had our excellent presentation yesterday about research and solutions in that aspect. I'd like to talk a bit more about sort of getting hands-on with the solution and actually creating a product. So more of um, sort of less, you use the research as your basis to actually create a finished product or solution. So the steps for today, I'll be going over just a quick introduction about myself, and then I'll go over what I consider the core steps when engineering solution, which are the problem definition, acquiring resources, creating the solution, iterations and improvements. We can go over an example from start to finish, and this is roughly the order of the solution lifecycle, but there's some overlaps and double backs and stages that don't have to be done in this order. It's not a problem. For example, you might have your team in mind before you pick your problem. So if you have a group of friends that you want to tackle something, so that would be an example. And the delineation between these are also, arbitrary. I separated them in a way that makes sense to me. Um, but so things might vary according to other resources. For example, some of the things I include in the solution section might instead be included in the problem definition instead. And that's fine. I really just want you to take away the gist of what I'm saying. Then afterwards, we can have some Q&A time where you can ask me anything about this workshop or anything about, my experience in general. Right. So about me, I'm a fourth year engineering physics student at McMaster University. I have a focus on electronics and optics. I have worked on a number of undergraduate teams. Most notably, I was part of the solar car team as a general member and later the solar car or solar cell team lead. And then I joined the Deep Space Analog Research Expedition team as one of the vice presidents as well as the electrical lead. Professionally, I've worked as a research assistant in a silicon photonics lab at McMaster, as well as working at Celestica this past year as a supply chain intern. And I have a small startup I'm running with a friend about selling horse trailer cameras. So overall, I have a good bit of variety of experience, some industry research and startups. So I'd like to hope I have a decent grasp of how project life cycles work in multiple situations. And so the purpose of this workshop is to describe this complete project and solution lifecycle. I intend for it to be a general description. Specifics vary based on the personal preference and the type of project that you're working on. I've seen a lot of projects fail, especially among students, generally because they're poorly planned. That can take a variety of forms. It might be overpromising on your technical abilities. It might be overcomplicating the problem and not accounting for the cost. And it might be that's not as scalable as a slightly inferior alternative. And I'll talk about these a bit more in the respective sections. And just as a small personal desire, I'd like to inspire some more analog projects instead of software. My heart's always been with, physical things, PCBs, electronics, even though, software's been booming, there's all the AI hype. I would like to see more analog solutions in the future. So problem definition, the first step of having a problem or solving a problem is having a problem. And it doesn't mean that you can just pick anything. You should be very deliberate and careful about how you're going to conceptualize this problem to yourself and how you're going to describe it to your fellow
Aló.
stakeholders. Mhm.
Muy buenos días, feliz fin de semana. Y desde las 7 de la mañana me estás pidiendo ese
Well,
señor.
once this is done, once you
De
have
9.
your problem, defined to yourself in a way that's clear and concise, you can say whatever you want to, people who aren't involved, as media promotion, casual family chats, or whatever. But anyone who's working on this project needs a very clear idea of what they're solving. As they say, a problem well defined is half solved. So often you're going to see a lot of people asking for a problem statement or projects that ask for a problem statement. You probably see that. in your future schooling if you have any with regards to that. That's fine. It's another tool you can use to define the problem. And there's a way that there's a lot of ways that you can do them. You can look online and see if any of those methods are appealing. I tend to stay away from them, at least at first, because I feel that narrowing the scope unnecessarily into like this strict format of the problem statement can lead away from these sort of non-problem problems, which often take the form of a desire, such as I want to help the environment. You can reframe that as a problem statement, but it might narrow your thinking. Um, so at least for me, initially, I don't pursue a traditional problem statement. But you can if you find that it helps you. So the requirements for a problem, the first requirement is specificity. You want to cut down on your problem by asking the questions, usually the classical who, what, when, where, and why, and how, until you're able to think about your problem in a concrete way that lets you solve it. And with each specific level of specification you include, you can think of the task on different levels, right? And each level has a solution that's more workable than the previous one. And that doesn't mean you should go all the way down. You shouldn't go too deep, or you can lock yourself in and jump into actually creating a solution without finding a good problem. So usually, if you start to name specific tools, you've gone to the realm of solution. And so to clarify what I mean by saying problem versus solution, since I'm using problem statements kind of loosely here, the solution to a question like how can I plant trees is not with a drone. What kind of drone? What kind of trees? You cannot make a product from the information from that statement. That only leads you to a more specific problem. I, in my mind, solution is synonymous with product. A problem is what you are trying to do. The solution is the product that does that. So we go back to that example, dropping trees dropping trees from the drone. You should specify, I want to do oak saplings. I want to use the DJI Mavic 3. I have a custom PCB that activates this sort of dropper. And so um, I would say that a problem statement is still general enough that you have a variety of options that you can use to solve it. And the second point I would like to mention when defining problems necessity is this specific problem actually worth being solved as opposed to spending resources elsewhere? If I think that there's not enough four-leaf clovers at the local park, yes, that's a specific problem. I could solve it, but is it worth it? Probably not. You should also have a target audience in mind, who you're designing for. This will guide the constraints in the later sections, um, as well as guiding your objectives, which are general goals that you're aiming towards. They don't have any hard limitations. For example, if you're designing an electronic device, you might want it to be very low power, but that's not like a hard limit, right? That's your goal that you're aiming towards, to have it be as low power as possible. Assembling a team. So for any long-term project, especially in this period of life, where a lot of it will be unpaid or volunteering, or it's a student team, having a good team is crucial to success. I've worked in a lot of teams, good and bad, and even having a single bad teammate can be catastrophic for the team culture. So, what is a good team then? So the first thing I would say is having a similar attitude and expectations. If one person sees the project as, sort of a side thing, they work on it when they feel like it, versus someone else who sees it as their main project, trying to turn into their full-time business, there's going to be a lot of conflict. Excuse me. Oops. So diversity in technical and non-technical skills, as well as viewpoints. So having this is not, strictly necessary, but having a diversity of skills in your team gives you access to technologies and informations that you would not have otherwise. If you have, a team of 10 people, but they're all only good at writing software, and you want to make a handheld device, it's not having more people doesn't benefit you. With regards to viewpoints, if you have, say, one person who grew up in a city versus another who grew up in the countryside, they'll perceive problems differently and have different understandings of their target audiences. And the sort of conflict that can arise between them leads to a more true understanding of the problem if the conflict is managed properly. And that generally leads to a more superior product. The team enjoys each other's companies. And again, I highlight this because we do a lot of unpaid or volunteer student things. It's not as necessary as the team grows larger and you get paid and working becomes less personal. There should be some baseline of tolerance for everyone on the team, and preferably you should get close to the people who work with you. This really helps with the motivation to work. It facilitates honest and just open discussions about problems, and just makes the entire process generally more enjoyable. And with luck, it gives you useful future contact. Leadership and communication. As the team grows larger and the project grows more complex, um, this becomes more important. So generally, as a problem is grows more complex, you begin to divide it up. You have your different sub-teams, and everyone becomes a bit more isolated in their corner of the project. But these sub-teams still need to remain aligned with their goal, and the leadership is responsible for managing this alignment and ensuring all deadlines are held. And I believe that their position as the leader should never be challenged by the sub-team leads under them, but only their opinion should be challenged. The leader must be free to lead in whichever direction, as long as they still have the team's best interest at heart, without needing to maneuver for their position. So the team will be your main technical resource at your disposal. And what do I mean by technical resources? So these resources fall into several categories. This is mostly to give a general idea of what's possible. Again, these are a bit arbitrary. This is how it makes sense to me. So there's technical resources, which are any form of technical information, skills, or technology available to the team to solve a problem. Aside from your team, you can have some other sources such as any teachers or professors, any industry contacts, relevant online guides or technology sponsorships. Um, for example, we have a number of software sponsored for free at the undergraduate teams. Economic resources, pretty straightforward. Personal funds, school or company allocations, any sponsorships, either monetary or in kind. In kind meaning that the company provides you goods and services instead of money. And social and political resources, these are a bit more vague, and they usually tie into the ability to acquire the other resources. So things like a social media following, association with other known groups and companies, and general public awareness. So my undergraduate team, dared the Deep Space Analog Research Expedition, is relatively new and was pretty unknown. So we had some trouble securing funding from school and sponsors, but as we put down roots, we showed up on events, maintained our social media presence. The visibility eventually gave us some opportunities, namely an industry sponsorship and an article and a radio show appearance, which gave us more status, and it makes things like the school more willing to allocate that funding. So you have your problem, your team, and what your team has to work with. So now we can move on to developing the solution. So again, when I say solution, I'm very practical minded. When I say solution, this is the part where you move beyond the idea and into the specific tools and materials you use. Uh, again, the solution to how do I plant trees is not with a drone. That's just a more specific problem. This is the part where you have a finished product, which is something that you could actually use. If the problem was well defined, it should be fairly straightforward to develop to begin developing the solution. I don't know what that would be, what that would look like, because it would be specific to your problem. But when you're working on this, the main thing um, to keep in mind would be that it remains within the constraints of the project. So what do I mean by constraints? These are things that are limiting your solution space. These are things that you cannot do. So the first would be your technical ability. Are you actually able to produce the solution you envision? I've had experiences where our leader was not able to accurately assess the team's technical ability, and we had to scrap all our progress and move to a downgraded version of our vision once it was proven infeasible. We lost a lot of time and money. And this one is a bit this one is one of the more difficult ones, as if you're inexperienced, you don't know how hard something will be unless you've actually done it before. Funding, pretty straightforward. Can you afford to develop the solution? Straightforward. As long as you're also accounting for any sort of hidden costs that aren't as upfront. You might allocate a budget theoretically perfectly to develop a product, but it doesn't account for errors or remakes, or you might miss things like export fees when shipping materials. So you have to really be careful when you're going in for funding. So those are the most obvious hard stops that you'll face. Um, but after a while, you want to look at some other things. So social and political constraints. Even if you develop the best technical solution in the world, if no one wants to use it, it's not a solution at all. Um, so this would include things like fear of the device or fear of the potential your device might have. If you have a drone that maps out, the wilderness flawlessly, but people are paranoid that you're going to use it to spy on them, and they lobby for it to be banned, well, then you've wasted your time. Regulatory, make sure you're following any regulations related to your product. Again, using drones, there's any area near an aerodrome is a no-fly zone. If you're doing something with software, you need to keep customer data, you secure it properly. But yeah, you just need to ensure that these development costs, time, and the technical requirements are included in the scope of the project. Scalability, since the topic of this event is focused on some large scale problems like sustainability, any solution you create should be scalable, meaning that it should be able to be deployed on a scale large enough to actually have an impact. So software generally is very scalable. You can duplicate as many times as you want. But if you're making a physical product or you want to make a physical product that relates to your software, you need to be careful about how, like whether or not it's realistic to be manufactured on the level that you want. Like if you have a device that is the best carbon captured thing ever created, but you can only make a unit every 2 years, it's useless. It might be a stepping stone to a superior one, but it's still useless right now. And I would say don't creativity is often encouraged, helps you find unique solutions, but I would say don't be creative just for the sake of being creative. Um, you need to be, again, like with the problem, you need to be deliberate about all the choices you make with your solution. If there's no actual reason to, design a thing in a unique way, it's probably not worth designing it that way. Um, there's a reason that existing products are not designed that way, even if you don't know it. But maybe there is a reason, or maybe there is a justification you can use. But just be careful about being creative. Don't go overboard, and don't be when you're developing your solution. You shouldn't be afraid to like reevaluate, return to any previous steps, or even switch off the problem entirely if you realize that's not feasible. So leveraging existing solutions, I would say that one of the most important aspects of developing a product is to use the existing solutions. Please do not try to reinvent the wheel. It's going to be hard, expensive, and it's going to take you a lot of time. And at the end, you're going to have something that's worse than what already exists. I could develop, a temperature sensor from basic electronic parts. I can spend tons of time fine-tuning it, testing it, making it work with all the rest of the equipment, or I can purchase one for less than $5. Um, and they're useful in other ways as well, by looking at existing sort of complete products that are related to the problem that you want to solve. You can identify any areas of strength as well as the areas of weakness, and that can help to inspire ideas and direct your team. And if possible, try to use existing products in your system when possible, as this will generally be cheaper and easier to work with. That means that the product you create might be suboptimal in some aspects, um, but generally speaking, it's better. For example, if you want to do more forms of public transit, um, here in Toronto, we have a system that uses the Presto card very ubiquitously. Um, so if you're developing a new form of public transit, you could try to develop your own fare system, or you can try to integrate it with existing systems like Presto. And that integration of existing system also helps you encourage adoption of your new system. They can also just make things like manufacturing costs cheaper, um, instead of uh, having hand create a new device for every, or if there's a part of your system that takes you a ton of time to assemble, or you can buy a commercial version. It's usually just better to buy the commercial version. You can leverage existing supply chains, and it'll also be easier for people to generally improve on, design with, and manufacture. Iterations improvements. Do not go for the perfect solution you have in your mind immediately. You generally won't be able to make it unless you're actually, quite experienced. Um, but resources will change. The problem might change, and you should still keep this ultimate goal you have in your mind, and keep it and have it as a direction for your current work. But you will be disappointed if you expect, your perfect product out of the gate. So generally, I would say aim to create your minimum viable product first, something that has enough features to attract these customers, early adopter customers, and they can help you validate the product idea. And then you can use any feedback they have during the usage to identify areas in lacking and attempt to improve upon those. So for my startup, we created our first minimum viable product using some 3D printing. We hand spliced wires and we used a commercial phone battery pack. So it's pretty low investment, and it's, a pretty low quality product to be fair. But we found some people who were interested in what we were selling, because it was substantially cheaper than anything on the market. And they used it for a bit. They found some problems. They gave us feedback, and we took that and made improvements to our system part by part. We improved the batteries first, and camera quality, and firmware, and we're still going. So what I'm saying is, don't expect it to be a one and done, especially if you want it to be something that's impactful. Um, Anything really impactful takes continuous improvement and a lot of revisions. Right. So I'd like to try to go through, um, a sort of complete design process here. So again, we're dealing with sustainability here. So let's say our initial thought is I want to help the environment. Um, but this is, again, like I said, this is not a specific enough problem definition. It's still too vague. There's still too many open possibilities. Um, so I'd like for the audience to help me narrow this down in the chat. So, ask those questions. Um, who are we helping? How are we helping? Stuff, and just propose some ways to specify this down in the chat, or you can unmute and speak up if you want. Sure, helping climate change specifically. So that's fine. Yeah, I want to help the environment by helping climate change. Okay, that's a good first step. So let's think about some more. What part of it is climate change is a thing. What causes it, right? So are we talking carbon emissions? Are we talking um, let's see. Well, I mean, carbon emissions, I suppose, is a large one. Um, sure, greenhouse gases. Yeah, we want to talk about greenhouse gases. Um, okay, so we want to help the environment by helping climate changes by reducing greenhouse gases. Okay, again, narrow that down. Where are those greenhouse gases coming from? How do we want to reduce those, or do you want to capture them by planting trees? Um, again, you want to keep narrowing this down again more and more. Okay, so there's a couple here. Sure, I see two with about fuel consumption. Okay, so we want to help the environment by reducing it for combating climate change by reducing greenhouse gases by reducing how much fuel we consume. Okay. Yeah, and I see this is already a kind of another step, reducing initiatives that promote less motor vehicle usage, right? Okay, how can we do that? How can we incentivize people to stop driving everywhere? And I see another one, waste management strategies in Latin American. Um, that's a good starting point again. But the again, waste management strategies, well, what kind? What kind of waste? Where exactly by communities? Are you talking about, small scale local villages? Or are you talking about industry? Are you talking about the big cities? There's a lot of questions here when you have these sort of problems. So electric cars. Okay. So you want to help the environment, reduce climate change by reducing our fuel consumption by using electric cars. And so is that your final step? Is that, you want to develop an electric car, right? And at this point, you could go ahead and say, yes, that's what I want to do. But also, I would also advise you, stop about it, think about it, stop and think about it for a moment. Electric cars. Is it feasible for you to develop an electric car where, there's Tesla, Toyota, Honda, whatever, all these giants of the automotive industry are already making electric cars. So yes, that's a solution, but that's not a solution that you can do, right? So here I would say, back up a bit and think about the problem more. Maybe yes, it's electric cars, but um, no, we can't make them. So is there anything we can do to perhaps promote their use or make mm, make it more convenient to use those or subsidize them? And I understand that, the research paper, you don't necessarily actually have to create your product. That's just how I think in terms of this, from an engineering mindset. I would not, the way I view it is I won't pursue a problem that I can't solve. Of course, it's slightly different for your paper and your presentation. I'm just explaining how I view things from my perspective. So renewable energy advertisements in neighborhood, um, creating a product as a solution. No, well, creating a product as a solution. Again, that's how I think about things. Um, I want to, if I'm doing something to try to, solve a problem, at least to my view, publishing a paper about it can help, but it's not, I prefer to get hands-on with it and actually get involved and start doing things. So yeah, it's a matter of perspectives. There's usefulness in both. I just want to explain how I think about things from an engineering mindset because I see a lot of I've been reading the introductions and I see a lot of people in a lot of the sciences more. So where we have just allowed to present our idea and research. I believe for this competition that's the case. If one of the competition organizers wants to confirm that. Um, yeah, so take what I say here with a grain of salt. Just keep this in mind. Like you can apply some of these principles when you're working on your competition submission. It's like the specificity in the problem, right? Or like being realistic about what you expect, right? So if you have a like something that reduces littering, and you want to say this product will make everyone 100% certainly with 100% certainty stop littering because it'll like send them a reminder or something every day to not litter. Well, that's not realistic, right? People will litter pretty much, well, no matter what, honestly. And actually, I'd like to use that example to talk about like the creativity for the sake of creativity or like misdiagnosing causes as well. So say we have littering as an example. Maybe your solution to littering is we have you know robots driving around the park with AI vision and they identify any trash on the ground and pick it up. That's fine. That would solve it. But again, you need to think about that. Is that a feasible solution? Is that a practical solution? You can step back a bit more. You can think about littering. Well, what's the root cause? it could be something as simple as there's not enough trash cans in the area, right? People litter because there's no trash cans within 3 kilometers. And so, yes, you could have your AI robots drive around and pick up trash, or you can, install a trash can every like 300 meters. Yeah, so we got a bit off track there, with regards to the walkthrough. I think, um, yeah, I think for the sake of, what you guys are going to do, we can leave it at that. Yeah, but just some key takeaways before we can continue our discussion with the Q&A. Um, when you're deciding on the problem, you should be clear and specific about what you're trying to solve. You should have a good team culture. You should be similar in your expectations. You should have some diversity in your skills and viewpoints. You need to set realistic objectives bound by your constraints. You need to once in a while take a look at your project and say, is this actually something that could work? You should leverage your existing solutions when possible. Um, don't try to reinvent the wheel for no reason. You should iteratively improve your solution. Um, again, you're not going to produce something perfect on the first try. So you need to, if it's something that you really want to pursue, if it's something that you think will genuinely make an impact, you need to keep working on it even after putting on a product. So yeah, um, we can go into the Q&A section. Anything about anything I said here, anything about my own life, or if you're interested in going into engineering in the future, I can answer any questions there. I don't know too much about the competition. I'm not one of the organizers. I'm just a guest invited on to present this. Okay, I don't think there's any questions then. So yeah, we can just end the meeting here. I wish you all the best of luck with your proposals, and have a great rest of your day.
All right, thank you so much, everyone, and thank you, Harry. This meeting is ending, so you're all free to leave before it ends. And if anyone has questions, I just made a workshop leads question chat in the Discord, so you're also free to ask there.